And we're live. Wow, 14 of 12 have answered this question. That's really impressive for you guys. 14 of you. 14 of the 12 of you answered this. Probably it scaled back to 12 because there's only 12 people in the class. But some of you, two of you took it. Or maybe one of you took it 3 times. Who knows? I certainly don't. Okay, we're back to... Oh, we're to 6. 6 concurrent viewers. Alright. I'm saying that's good enough for us to get started. Let me do one thing before we... Yeah. That's exactly what I wanted. In case y'all message me in Discord, on Tuesday, I did the whole stream and went to stop the stream and looked, and I hadn't started the stream in the first place. And I happened to glance over at Discord, and everybody was like, there was like 100 messages in Discord going, is he going to start anytime soon? Oh, that story ran off 3 people. Screw you guys, it was a good story. They're slowly coming back. Alright. Let's get started. We got a long ways to go and a short time to get there. What value remains the same at all points in a series circuit? Well, that is going to be current flow. In a series circuit, there's nowhere else for current to go. So once it leaves the battery, it has to make its way back to the battery in the circuit. It's like if you had a closed loop, like you took a water hose, hooked it to a pump, and hooked the other end of the water hose to the pump, like to the other end of the pump, and you just circulated. The water that enters the hose is going to come back to the pump. It's not going to go anywhere else. It's going to have the same amount of current flow through that hose at all the points. How many possible values do you need in order to find all the other values? You only need 2 values. With all the formulas we have, you only need... excuse me. You only need 2 values to get recently added. I need to add paint. Let's do that right now. Pin to start. So we've got a handful of formulas. I am so sorry about that noise. That was terrible. I did not know that would squeal like that. Alright. So you've got a handful of formulas, and we're going to start by talking about my favorite way. I will get to the formulas later. We'll talk about my favorite way of doing all of this, and that is by making a chart. So this is resistance, current, voltage, and power. And the way this works is if you have more than one of each thing, you put the top row as your totals, and you put down below it R1, R2, I1, I2. And so on and so forth. So, depending on what values you have will determine your formulas. If you are taking 2 rows or two columns and trying to go this way. So R times I will give you E. So if you're going this way, you multiply. If you were going this way, you divide. So let's and that's a simplified way of saying it. Uh, I don't want a brush, I want a pencil. So if you're going this direction, so P divided by E will give you I. E divided by I will give you R. Then going the other direction, R times I will give you E. I times E will give you P. When you're dividing, you can skip a column. So if you're going this direction, you can skip a column to get the column that you skipped. So P divided by I will be equal to E. Ooh. I don't know how to go forward. I don't know hotkey for that. Okay. And then same thing, E divided by R will come back and give you I. Does that make sense? I hope it does. This is my easiest way I've been found to explain Ohm's law. The actual Ohm's law formulas are in the form of circles. So let's grab some lines. You know what I should do is just, and then select Control C, Control V. Control V. Control V. That's so much faster than drawing it 4 times. Okay, let's write our numbers. So, in the first one is something we have done already. E, R, I. Then there's pi. Then my favorite, ERP. And peer, I don't have a, this one doesn't make a word. Pi squared R. You only need to remember these two. These two are the most important. I didn't misspell that. You didn't see that. Okay, these two are the most important. This one's good to know. And then this last one is an alternate. So, this chart up here covers these two. You do not need to know these two if you can work the chart. This third one covers something that the chart doesn't cover at all. If you only have P and R, you can't, those two don't interact using the chart. You will have to know this formula if you get into a situation where you can't find any other value except for R and P. So, That is a way more in-depth answer to this question than probably anybody expected. Y'all thought that was a throwaway question, but no. The opposition current flow provided by resistors adds together. Going back to my beautiful artwork. Let's clear up this top area. Yeah, that's good. Alright, so we've got this. If you have multiple resistors, how do you combine them together? Well, you just add them together. Same thing with voltage in parallel, or voltage in series, and power in series. All of that stuff adds together. Current is the same everywhere in the whole circuit. So, resistance adds together. Current stays the same, voltage adds together, and power adds together. Whenever we start working circuits, you'll see the beauty of this that was the wrong button. This chart kind of shine, because once you start putting values on the chart, you'll be able to see how they work together without, having to... It'll keep everything straight. One of the most important things when you're working a circuit is to keep all of the numbers neat. I can't tell you how many times I walk around a room of people working circuits and look down at their page and they just have they have numbers everywhere. And they're like doing work 3 or 4 times to get okay, I lost the number, I'll have to do that math again. Nobody likes doing math again. Some people like doing math the first time, though. You have to watch those people. Yeah. To read resistance with a meter, you do have to disconnect power from the circuit. Because of how the meter reads resistance, it can get damaged if you have power on the circuit. Series circuits only have one current path. Voltages of batteries add algebraically. What that means, if you have a battery facing the opposite direction of the other batteries, it will actually subtract, while most of the batteries will add up. Larger resistors will drop more voltage than smaller resistors. What happens there is, since current stays the same through the whole circuit, if you have 2 amps, well, it's 2 amps everywhere. And then so this is the bigger resistor. It's going to drop 20 volts, because 10 times 2 is 20. Then 5 times 2 is 10. 15 times 2 is 30. You can see I multiplied across, but you can double check yourself by adding things up in the row. So 10 and 20, 30. Done. We solved it. 10 and 15, or 10 and 5 is 15. So our numbers add up to the total. And if you multiply across or divide back across, you can check yourself. Voltage is different is the difference of potential. We already covered that in so much depth, right? Just so incredibly much depth. When solving unknown values in a series circuit, a person should always double check his or her work. Just covered that. It's like I know what's coming. When working with a series circuit, Ohm's law formulas can be manipulated. double check the work. Yeah, that's the same question. All right, let's go to our current results. Got a lot of people that didn't come back for the second quiz. That's weird. I'll have to message them. Of course, they got 15 minutes. Hey, we are right on time for the second live stream. Welcome to the second live stream of the day. We will be covering resistance and current. Give people... we got 6 to 12. I think that's my best percentage all week. Of like people actually in the class and people attending. So, resistance of the connecting wires in a circuit is generally less than the resistance of the load. That's pretty obvious. A load is going to have much more resistance than a piece of wire going to the load. And I literally just said this a few minutes ago, so I'm not going to repeat myself. That might make us go through this a little bit quicker. Keep looking in the wrong spot. Camera's there, not there. All right. Values are added. Resistors add together. That is Ohm's law, as we see here. But I don't really cover Ohm's law in the form... I kind of deconstruct Ohm's law into a different form, and a lot of my students probably couldn't write Ohm's law down for you. They can make the chart and they can work a circuit, but I don't know that they can write Ohm's law. I do things different than a lot of people do, so, yeah. Alright. What was total resistance in this circuit? Well, we determined that resistance adds. So all you have to do is... Oh, wow. Never mind. Y'all got this right. Y'all knocked it out of the park. Good job, guys. I got 1, 2, 3, 4, 5, 6, 7. Got 7 people that did it, and 6 people in the live stream. So all of you guys knocked it out. I mean, why would you be in the live stream if you hadn't done the quiz, right? I got a song stuck in my head. It is not necessary to disconnect the power. We just covered that. You know, doing multiple quizzes in the same live stream kind of makes it go, oh, I just covered that like 5 minutes ago. Of course you have to disconnect the power because it can damage the meter. And if the meter gets damaged, it could blow up in your hand. Like, that's like a worst case, like 7 different things failed all at once and there was an explosion type situation. The more... Oh, sorry. I bumped my mic. The more important thing to pay attention to is that you don't... that you don't put the meter on the wrong voltage. Generally, that won't happen to you guys. The meters that we use are rated up to 600 volts. But be aware, if you put that meter connected to something over 600 volts, the meter could explode. Because it is not designed for that higher voltage. And that's what happens when you put things on a higher voltage than they're designed for. Total resistance of this circuit is 120. What is the value of R1? Oh, so in this case... Oh, y'all got it. You all got it. It's 50. What you're going to do is you're going to take that 120 and subtract the 3 given values, which add up to 70. I feel like some of y'all are watching the videos as you go through. Of course, I've been labeling these really shitty. If you're going to my channel and trying to watch my streams for this stuff, I'm sorry. I've labeled them all the same, and I guess you could look at what time they streamed at. I don't know, I haven't been to my channel. I should probably, like, clean up my channel a little bit for you guys. Solve for the resistance of resistor R1 in the circuit. So, you have 220 volts and 5 amps. Pin. Let's clear. I should really just make up a nice, clean version of the chart and, you know, scribble all over it and then just bring up a new one every time. Alright, we have 220 volts. I don't have a marker. 220 volts and 5 amps. Was it 5 amps? It was. So, sorry, I lost my spot. 220 volts and 5 amps. What you'll do is I drew my 220 divided by 5 gives you, I want to say it's 40, but it looks like it's 44. So good job, 44. Subscripts allow us to communicate precisely with various components of a circuit by identifying each component with a unique label. Everybody all week has gotten this one correct. Good job. Subscripts are the little numbers underneath the letter that lets you know this is R1 and R2. Alright, since there is only one current path through a series circuit, the current has to go through the whole circuit. There's nowhere else for it to go. Oh. Fuse and circuit breakers are wired in series with the load, because if you wired it in parallel with the load, it wouldn't do anything. The current would just go around it. And then even if it tripped, it would still be just going around it. You've bypassed your switch. Or your circuit breaker. Current in a series circuit becomes smaller after passing through each resistor in series. Oh, we got some more people doing it. Everybody's in the room. Except for Josh Latte. Piece of shit. And Tyler Whiteside. But he's from Woodville. He probably doesn't even have internet. The current in a series circuit becomes smaller after passing through each resistor in series. It does not, because current stays the same all the way through the series circuit. Solve for the total circuit current in the circuit. So, this is another case of alright. I forgot what the numbers were. 30 and 60. We got 30 volts and 60 ohms. So what you're going to do is you skip the middle. So 30 divided by 60 will give you 0.5 amps. And then that will be 0.5 amps at all the spots in the circuit. But I believe this circuit only had one component, so there's no use to having multiple rows. All right. I'm going to give those stragglers a second to get caught up. Looks like somebody did it while we were going over it. Looks like it was Hunter, because whenever we went through it, everybody had these right. All right. I'm just going to give, because some people like wait till the last minute, so I'm going to give everybody a chance to catch up. So the new quiz will be going live at 11. I will stop the live stream here. Maybe over lunch I'll look through the channel and try to clean up some stuff. Maybe I'll watch my own videos. Haven't done that yet. I have no idea what y'all are getting. Yeah, the new live stream will go live at 11, or not 11. The new quiz will go live at 11. The live stream will be at 1:45 as planned. You do need to go pick up your tests. Unless you are more than 50 miles away from the school, then make arrangements to get the test mailed to you. You will need to get it back to the school by your next class and pick up the new test at the next class. I expect that they're giving you guys instructions whenever if you get the test mailed. I assume they're giving you instructions about, like, when does it need to get back. But you have 2 weeks to do 2 open book tests that you can use your homework. If the Socrative is up, I can't stop you from using it. I'm not putting questions directly from the test on the Socrative, though, so there won't just be like something like that where it's a straightforward, like, oh, well, here's all the questions. Yeah, see, Aaron's getting on. Just waiting on Josh and Tyler, and Josh lost power, so he has no power. And like I said, Tyler's in Woodville, so he probably doesn't even have internet. But everybody got the first quiz done, which is the really important one, because that's like, hey, everybody was here at 7. Let's see how Aaron does. Yes. He's thinking about this one. He probably doesn't know we're watching. What's this one? Oh, he doesn't know the formula. A good thing to have, and I have it underneath some mail over here. DC Theory book. This book has all the information you really need. Oh, let's turn it like that. There's a glare. Yeah, that's better. Maybe like that. That might have less of a glare. Let's see what we got. Okay. Anyway, I'm garbage at showing things off. Oh, we got it right. Good job, Aaron. Okay, it is 11. So I might give Aaron like 2 more minutes just so he can finish this, because he hasn't done it yet. So all right, but I'm going to get off here. The new quiz will go live in any moment.